we see that logarithms are related to exponentials. At this point, well, I guess we haven't seen these things at this point. Let me just say that there are three basic laws that I call the most essential. And then there's some other basic laws, most of which we've seen, as you'll see in a minute, that are also pretty essential. Okay, one law is that log to the base b of b to the x equals x. That just states that log to the base b and b to the x are inverse functions. And we've seen that in the context of the log to the base 5 function. We assert it for any base. So that's essentially just the definition of the log. If the log is found by reversing the columns of the b to the x table, if log to the base b is found by reversing these columns, then this has to be true, and you can tell that just by looking at those two tables carefully in the right way. Another property is that the log of a times b is the log of a plus the log of b. Okay, now where does that come from? That doesn't look like any law that you've ever seen, does it? I mean, you want to say that the log of a plus b equals the log of a plus the log of b. But that's not the way it works out, because the log is not a linear function. There is precedent for this idea. Let's go to exponents. What's x to the a times x to the b? It's x to the a plus b, isn't it? So we see that here we have a multiplication that leads to an addition. And here we have a multiplication that leads to an addition. Now, it's in slightly different form, and you can really think about how this is related to this, and if you understand logarithms pretty well, you can even understand how this law leads directly to this law. If you just turn this law for exponents around into law of logarithms, this is what you have to get. Another law is that the log of a raised to the b is b log a. Not log a raised to the b, but the b comes out in front and we get a b times the log of a. Now how does a power get translated into a multiplication? Well, again, it comes about because if you do x to the a to the b, you get x to the a times b. Here's a power that gives you multiplication. And if you apply logs and again turn around this law of exponents into logarithms, you do get this property. Now the rest of these properties are either things that we've already seen or things that follow from these properties. For example, the law of a divided by b is the law of a minus the log of a minus the log of b. That's related to the fact that x to the a over x to the b is x to the a minus b. Again, applying the properties or the definition of a logarithm to this will give you this. This could also be obtained from these two laws. A over b is a times b to the negative 1. The log of a times b to the negative 1 would be the log of a plus the log of b to the negative 1. But the log of b to the negative 1 by this law is going to be negative 1 log b, and we get this. So it's easy to derive that from these two properties. This isn't really anything new, but it's still a useful thing to remember. This is just an inverse property. B to the log base b of x equals x. It's just the other side of this inverse property. Log to the base b of x, as we said, is log x over log b. That isn't something we really have to assert. That kind of follows, it follows from these three laws in a way that we're not going to get into, but it certainly does follow. And finally, there's one more down here. The log of 1 equals 0. Now think about this. On the table of 10 to the x, you have the point where x equals 0 and y equals 1. When you turn that around, you get x equals 1 and y, which is the log of x, is 0. So the log of 1 has to be 0. And this is true for any base. Doesn't matter what the base is. And it's related simply to the fact that 10 to the 0 equals 1, which is where that line in the table that we switched around to get this came from. So there's nothing new and mysterious about these, but please understand that I absolutely require that at all points in this course From now on, you know these laws of logarithms as well as the laws of exponents. This is irreducible. It's something you can't get by without remembering, and I can quiz you on it or test you on it any time from now to the end of the semester.